Ever wondered what makes a solution ideal or non-ideal? Well, the world of chemistry holds the answers to these intriguing questions, so buckle up as we unravel the mysteries of solutions. A solution is a homogeneous mixture of two or more components. For instance, when sugar dissolves in water, it forms a solution where sugar is the solute and water the solvent. The concentration of a solution can be expressed in a variety of ways, such as molarity, molality, mole fraction, mass percentage, and so on. Now let's look at something called the vapor pressure of a solution. This is the pressure exerted by its vapor when it is in equilibrium with its liquid phase. The fascinating thing about vapor pressure is that it depends on the nature and amount of solute and solvent. This leads us to Raoult's law. According to this law, the vapor pressure of a solution containing a non-volatile solute is directly proportional to the mole fraction of the solvent. In other words, the more solvent you have, the higher the vapor pressure. When a solution obeys Raoult's law at all concentrations and temperatures, we call it an ideal solution. An ideal solution has no change in volume or enthalpy upon mixing. A classic example of an ideal solution is a mixture of benzene and toluene. On the other hand, a solution that deviates from Raoult's law is a non-ideal solution. It may show positive or negative deviation, depending on the intermolecular forces between the solute and solvent. When the vapor pressure of the solution is higher than expected, it's a positive deviation. When it's lower, we call it a negative deviation. For instance, a mixture of acetone and ethanol shows positive deviation, while a mixture of chloroform and acetone shows negative deviation. Now let's shift the focus to colligative properties. These are properties of a solution that depend only on the number of solute particles, not their nature. They include relative lowering of vapor pressure, elevation of boiling point, depression of freezing point, and osmotic pressure. The relative lowering of vapor pressure of a solution is equal to the mole fraction of the solute. The elevation of boiling point of a solution is proportional to the molality of the solute. Similarly, the depression of freezing point of a solution is proportional to the molality of the solute. Lastly, let's talk about the osmotic pressure of a solution. It is the excess pressure that must be applied to a solution to prevent the flow of solvent into it through a semi-permeable membrane. This is given by the equation where Pi is the osmotic pressure, m is the molarity of the solute, r is the gas constant, and T is the absolute temperature. So, in summary, an ideal solution obeys Raoult's law, showing no change in volume or enthalpy upon mixing. A non-ideal solution deviates from Raoult's law, showing either positive or negative deviation. The properties of a solution, including vapor pressure, boiling point, freezing point, and osmotic pressure, depend on the nature and amount of solute and solvent. Understanding these principles can help us grasp the complex world of solutions in chemistry.